Terrestrial planets, inner planets. Earth, Mercury, Venus, and Mars, these planets are small, rocky, and closer to the Sun. They are less dynamic compared to the gas and ice giants. Gas giants, outer planets. Jupiter and Saturn, massive planets primarily composed of hydrogen and helium. They exhibit extreme weather patterns and fascinating atmospheric phenomena. Jupiter, the largest and oldest planet in the solar system, featuring intense storms like the Great Red Spot and a massive magnetic field. Saturn, known for its striking ring system, likely formed from the remnants of a destroyed icy moon. Ice giant. Uranus and Neptune, classified separately due to their distinct compositions and smaller sizes compared to gas giants. Uranus, known for its tilted axis and cold temperatures. Its methane-rich atmosphere gives it a bluish hue. Neptune features the fastest winds in the solar system and intense storms, despite its distance from the Sun. Key highlights: formation. Gas giants formed beyond the snow line, allowing for accumulation of icy and rocky material. Core and atmosphere. These planets have rocky or liquid cores surrounded by thick atmospheres of hydrogen and helium. Rings and moons. All gas giants have rings and moons, with Saturn's being the most visible and prominent. Unique features. Jupiter's red spot, a storm larger than Earth, persisting for centuries. Saturn's rings, formed relatively recently and replenished by material from its moon, Enceladus. Uranus's tilt likely caused by a massive collision, resulting in a unique sideways rotation. Neptune's storms, more volatile than any other planet's weather. Here's the rewritten and punctuated version of your provided content. Exposing the core. If the outer layers of a gas giant are stripped away, what remains is a hypothetical type of planet known as a cathodian planet, essentially the old, dead core of a gas giant. While these remain speculative, we do know that gas giants thrive better beyond the snow line of a star system. Mini-Neptunes, gas dwarfs. This brings us to another type of planet, gas dwarfs, better known as mini-Neptunes. These planets are named for their similarity in mass and composition to Neptune, rather than Jupiter. Formation. They form from large rocky cores that accumulate thick layers of hydrogen and helium, resulting in a diameter 1.5 to 3 times that of Earth, though smaller than Neptune. Composition. These planets often house deep layers of ice and rock, and potentially liquid oceans of water and ammonia. Hot gas dwarfs. These exist, but are rarer, as their atmospheres are more prone to hydrodynamic escape when orbiting too close to their parent star. Mini-Neptunes are usually found beyond the snow line, where icy materials can persist. Many of these planets were discovered during the Kepler mission, 2009 to 2018. Example, Kepler 138d is the smallest known extrasolar gas dwarf, about 60% larger than Earth, but with similar mass. This indicates it may have a significant water content or a thick gas envelope. Super Neptunes, these larger counterparts, 5 to 7 times Earth's diameter, are rarer, as they require far more gas to form. V1400 Centauri. Ring systems vary among planets, but one extraordinary example is V1400 Centauri, discovered in 2012. Located about 430 light-years away, it boasts a colossal ring system. Size, over 200 times larger than Saturn's rings, with a combined diameter exceeding 120 million kilometers. Impact. If placed in Saturn's position, the rings would dominate our night sky, appearing larger than the Moon. Light dimming. During its transit, the rings block 95% of the light from its parent star, a stark contrast to the fractional dimming caused by typical gas giants. This ring system may host moons formed from its abundant material. Over time, these satellites could clear the rings, potentially creating large, even habitable moons. Brown dwarfs and failed stars. At the largest end of the gas giant spectrum are cold super-Jupiters, some of which grow to twice Jupiter's size and several times its mass. However, beyond 13 times Jupiter's mass, they blur the line between planets and stars, becoming brown dwarfs. Brown dwarfs, these are objects that can fuse deuterium but not hydrogen, unlike stars. Sub-brown dwarfs, free-floating objects that fail to sustain fusion and thus resemble rogue planets. Regular brown dwarfs, heavier, 13 to 80 times Jupiter's mass, they eventually cool and fade over time, becoming nearly undetectable. While sometimes called failed stars, gas giants are brilliant entities in their own right. Unlike brown dwarfs, they were destined to be planets from the start, growing from rocky cores. Gas giants and ice giants play a crucial role in planetary systems. They might not shine like stars, but they support moons, ring systems, and extreme weather phenomena. Their immense gravitational influence shapes the formation and evolution of planetary systems, making them pivotal to the history and destiny of our own solar system. These godfather planets continue to amaze and inspire us as we uncover more about their complexity and beauty.